So for our test over this unit, we're going to have 20 questions, and those 20 multiple choice questions are going to involve this first part of the review. Make sure that you do your definitions and that you study those because that will be part of the review. Also, make sure that you can use the activity series and the solubility chart. Now, I've included this, and we will be looking at this from time to time, going through this review, hopefully fairly quickly. But you need to be able to use the activity series. Now, keep in mind that this is the metal activity series. You're going to want to use your periodic table for the non-metal activity series. The list of the halogens in order, fluorine, chlorine, bromine, and iodine, that is the activity series for the non-metals. So be sure you can use this. And make sure that you can use your solubility chart. Again, we'll be looking at that as well, determining whether substances are soluble or insoluble. So in addition, besides using those two items from the handout, you need to know the three driving forces of a double replacement reaction. Those are formation of a precipitate. I'm going to abbreviate that PPT for precipitate, formation of a gas, and the formation of a molecular compound. So those are the three driving forces. We really only emphasize formation of precipitate in this class. We kind of say formation of a gas and molecular compounds for AP, but you do need to know that they are driving forces. Now, as far as symbols are concerned, knowing that a solid as a reactant is a small s, a solid as a product, or a precipitate formed, I want to see a down arrow for those. If it's a solution in water or aqueous, it's AQ. When they show a catalyst, the way they show that is to put the catalyst over the arrow to show that that's speeding up that reaction. If they add heat to a reaction, they show that by putting a triangle, which actually is the Greek letter delta, over the arrow to show that heat has been added. A gas, they're going to show as a small g. If it's a reactant, I like to see an up arrow right now, just so you're used to seeing those symbols. And then, of course, a liquid, no matter where it is a small l. So those are the things, along with balancing equations, types of reactions. Those are the types of questions you're going to see on the multiple choice part. Remember, 40% is multiple choice. 60% of the test comes from the rest of this discussion for the review. So the first thing that you want to do whenever you write these and predict products and write these chemical equations is to determine what type it is. Now, sometimes it'll be a dead giveaway if it says combustion or it says burn. Burning is burned, etc. Then you know you're dealing with combustion. So label that. This is actually not propane, this is butane. I think that was changed, perhaps, I'm not sure, on your worksheet, but that is butane, not propane. But it doesn't really matter because all you care about really on this is the formula, which is C4H10. The thing that people leave out all the time is the oxygen. You need that oxygen in order to combust or burn this. And since it emphasized complete combustion, CO2 plus H2O. Remember, if it's incomplete combustion, the only thing that changes is that instead of getting CO2, we get CO, carbon monoxide. We also get the water, but the carbon compound changes. So keep that in mind. Once I have this, what's left is to balance. So I'm going to put those blanks in front. Remember the order to balance for combustion. Balance the carbon first, then the hydrogen, then add your oxygens. So carbon looks like I need 4 in front of the carbon. Since I have 10 hydrogens on the left, I'm going to need a 5 in front of the water to get my 10 hydrogens over here on the right. what that gives me in terms of my oxygens, I've got 4 times 2, that's 8 oxygens here. I've got 5 oxygens here for a total of 13. Now what happens when you have odd oxygens? You have to double everything. So I'm going to go back in and double everything. I'm going to double this to a 2. Double this to an 8. I don't put in anything in front of the oxygens yet because that's the whole purpose of this, is to figure out how many oxygens I have. Double the 5 to a 10. Double this 8 to a 16, the 5 to a 10. This is going to become 26. And now if I've got 26 oxygens on the right, how many do I have to put on the left? Well, since I've got 2 here, I need to put 13 in front because 13 times 2 is 26. And when I box this, make sure it's a clean box. I don't want to see really any arrows or anything. Please make sure, it's hard for me to erase on this smartboard because it keeps erasing things I don't want to erase. But when you do these, don't just write over the numbers or cross them out. You erase them and write them correctly. Okay, so that's our combustion reaction. Let's go on. There's going to be 1 addition, 1 decomposition, 1 combustion, 1 single replacement that works, 1 single replacement that doesn't work, 1 double replacement that works, and 1 double replacement that doesn't work. That's what's going to be on the test. So okay, let me get this erased so we kind of have a clean area to work with. Remember to label. If it doesn't say combustion, label to see what you've got. This says we're dealing with barium nitrate and potassium chloride, 2 compounds. If I have 2 compounds, then this is going to be a double replacement reaction. Tell what type of reaction it is first. Please do yourself a favor, guys, and write this equation in words. If we have barium nitrate, and I'm going to start this a little further over to the left so I have plenty of room. If I have barium nitrate plus potassium chloride, when that reacts, remember the best way to do this is just to simply take those first 2 elements and trade places with them. So I'm going to put the potassium with the nitrate, and I'm going to start writing small here because I really didn't write as small as I should have to start with. So the potassium goes with the nitrate, and the barium goes with the chloride. And it doesn't matter if you put barium chloride first and potassium nitrate second. And I had to really scrunch it together there, but as long as they're with the correct partners in the correct on the correct side of the arrow. Okay, so writing these down, I've got barium with nitrate, and I'm not going to worry about charges yet until I write down the compounds. Potassium goes with chloride. Guys, remember that 8. If it ends in 8 or ite, it's going to be a polyatomic ion. Look it up. Don't just write down N. 8 and ite means it has oxygen in it. So barium, look at that on your periodic table. Hopefully, you remember you're not going to get to use your own, so you have to memorize those charges. Make sure you know your charges, including those islands in the middle in our sea of unknown charge. So barium's a +2, nitrate, if we look it up on the orange sheet, is going to be a -1, or on your resource materials is a -1. So we're going to need this. Not this, this, a 2. And potassium's +1, chlorine's -1, so it doesn't need any subscripts. Potassium nitrate is K with the NO3. And barium chloride is Ba with Cl. Now find your charges. Potassium's +1, nitrate's -1, so no subscripts needed there. Barium +2, chloride -1. Looks like we're going to need a 2 here. Now, this is one of the types of reactions that may not work. And remember, the way we know this is to decide if one of these 2 products forms a precipitate. One of these 2 products must be insoluble or this reaction will not work. So we've got potassium nitrate and barium chloride. And one of the things that I've asked you to remember is to notice that the alkali metals, the group 1As, those are always soluble. So group 1A, anything with nitrate in it and anything with NH4 ammonium in it is going to be soluble. Everything with those in it is soluble. So if you see one of those in the compound, then you know it's not going to be the precipitate. So what do we see over here with our potassium nitrate? Potassium is a group 1. So this one is soluble. Nitrate is also one of the ones that's always soluble, so that's like doubly soluble, so that's definitely not the precipitate. So let's look up barium chloride. Let's go back over here and let's see if either barium or chlorine are on here. Well, there's chlorine right there, and it's in the soluble list, and barium is not one of the exceptions. So it looks like our barium chloride is soluble too. Well, if that's true, then that means this is soluble as well. That means this does not react. No reaction. And that's what I want to see for this one. No reaction. The other one on this page, we've got aqueous aluminum chloride, which is a compound. And oh, by the way, on this one, you can box it. Probably a good idea to box that whole thing to show that you don't have a reaction here. So the next one, we've got aqueous aluminum chloride. So we've got a compound, and it's reacting with bromine, which is an element. So this, when you react a compound with an element, you get a single replacement reaction. So that's going to be SR, single replacement. And now we have to decide who's trying to bump out who. We've got aluminum chloride, aluminum with chlorine, and we've got bromine. Go ahead and find your charges. We know that aluminum is +1. Excuse me, +3, sorry. Aluminum is an always true +3, and chlorine's a -1. So it looks like we're going to need a 3 here. And remember, for our elements, all we need to know is whether they're part of the diatomic elements, the red 7, which, by the way, you need to know those. So bromine is diatomic. So it's going to be Br2. And now we have to decide who's going to try to bump out who. Our single element is going to try to bump out somebody. It's going to bump out the other element that is like it. Bromine is a nonmetal. Be a good idea to label this as a nonmetal. Chlorine is a nonmetal. Aluminum is a metal. We're always going to have like bump out like. So bromine is going to try to bump out chlorine. You can also tell which ones are trying to bump out because if you look back at your list, they're going to be in the same list. Okay, bromine's not going to try to bump out aluminum because aluminum's over here in this list and bromine's over here on this list. It can't bump out aluminum. They're not even in the same list. But it can try to bump out chlorine. Can it bump out chlorine? No, it cannot. It can't bump out chlorine because it's lower than chlorine on the list. Chlorine is stronger. So bromine won't be able to bump it out. What does that mean? It means that we have no reaction. So we don't have to find anything else out about this reaction because it's a no reaction. And again, it would be probably a good idea to make sure your arrow's down a little low so you've got a clean box and you're not trying to put anything in there except for just the reaction. Okay, so moving on. Iron 3 oxide decomposes into its elements. That's pretty much a dead giveaway. That's a decomposition reaction. So we've got iron with oxygen. It said iron was a +3, oxygen is a -2. So it looks like this is going to be, remember we can change or switch the charges, cross the charges. So iron gets the 2, Oxygen gets the 3. It decomposes into its elements, so iron and oxygen. Now watch it, guys. Don't forget your diatomic elements. Remember the list for our red 7, our diatomic elements. Our hydrogen 7 is hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. Make sure you know those. Iron is not in the list, so we don't put a 2 after it, but oxygen is right there. So O2. So all that's left to do now is to balance. Looks like we need a 2 in front of the oxygen here and a 3 here to get 6 oxygens on both sides, and a 4 here to get our ions balanced. So there's that reaction. Our next reaction says we have a piece of sodium, that's an element, placed into a solution of cobalt 3 sulfate, that's a compound. Looks like once again we have a single replacement reaction, an element plus a compound. So sodium is going to be reacting with cobalt sulfate. So make sure you look that up. It's SO4. Sodium is an element. Is it diatomic? No, it's not on the hydrogen 7 list. Cobalt is a +3. Look up sulfate on your polyatomic ion list, -2. So it looks like we're going to cross charges again and get this. Now, is it going to react? Who's trying to bump out who? Well, the single element is always trying to bump out. So sodium is going to try to bump out. It's a metal. Cobalt's also a metal. So that's who it's going to try to bump out. Can it bump out cobalt? Let's look on our list. Can sodium bump out cobalt? Here is sodium. Here is cobalt. Yes, it can. Sodium is definitely stronger than cobalt is, so it can bump it out. We only look at that activity series for our single replacement reactions. So since it can bump it out, this will react. This is a really sloppy reaction right now, and I don't want it to look like that if I'm taking a test. So I'm going to rewrite it so it looks good. Cobalt's going to be by itself now, and sodium is going to be with sulfate. Make sure you find your charges. Sodium is a +1, sulfate's a -2, so we're going to need a 2 here for our sodium. Cobalt is not one of our hydrogen 7, so it does not need a 2 after it, and all we have left to do is balance now. Looks like our sodiums are not balanced, but I think our sulfates will be the hardest thing to balance. Since there are 3 of them here and only 1 over on the right, I'm going to put a 3 here to balance the sulfates. That's going to give me 6 sodiums here. So I'm going to put a 6 here in front of the sodiums. And it looks like the only other thing I need to balance are my cobalts, so I'm going to need a 2 here. And there's my balanced chemical reaction for this particular problem. Okay, the next one, liquid mercury and solid iodine. So I've got mercury, which is an element, and iodine, which is an element, 2 elements. That's my addition reaction. So I'm going to be reacting mercury and iodine. What's the only thing I need to know about it if it's an element? If it's diatomic. Mercury is not, but iodine is on my list. So that's going to form the mercury 2 compound. What does that mean? Well, when I put Hg and I together, don't make the mistake of carrying that 2 over, at least not yet, because it's not diatomic when it's in a compound. We have to find charges. And since it's forming mercury 2, that means it's going to be a +2 for mercury, -1 for iodine. So this time I am actually going to need to put a 2 here, but it's not because it's diatomic. It's because the charges tell me I have to. So there is my reaction. Looks like to balance this, I don't have to do anything. It's already balanced. If it works, don't fix it. So there's my final reaction for this one. Finally, for the last one, I've got a solution of lithium phosphate with barium nitrate. Both of them are compounds. Looks like this is double replacement for my type of reaction. So double replacement, I think, will be easier for you if you just write out the words first. Lithium phosphate plus barium nitrate. Remember, the best way to do this is just to flip out those first two elements. So we're going to take lithium and barium and flip-flop them. We're going to put the barium with the phosphate. And we're going to put the lithium with the nitrate. And now we're going to write our reaction. Watch your 8s. They're all polyatomic ions in this one. So lithium with the phosphate, look it up on your orange sheet. At least it's orange this particular year. It may be another color another year, but reacting with barium and nitrate. Now, once you've got the substances written down, find those charges. Lithium's +1, phosphate's -3. So it looks like we're going to need a 3 with the lithium. Barium is a +2. Nitrate is a -1. So it looks like we're going to need to do this to get the formula for that compound. Barium phosphate for our product, barium with the PO4. Don't let your guard down. Make sure you don't put a P on this side accidentally after you did so good putting a PO4 on the other. And lithium, again with a nitrate. Finding charges, we already found them on the other side. +2 for barium, -3 for phosphate. So cross those charges. +1 for lithium, -1 for nitrate. That one you can just leave alone. But now this is double replacement. We have to make sure that this reaction is going to work. So look back at our chart. We need to see if we get a precipitate, if one of these is insoluble. Now, lithium nitrate, let's look at that one first. Let's come back here. It's got nitrate in it. Lithium is also a group 1A element. So this is another example of one that is, and I went the wrong way. This is another one that is an example of, that's one that's like doubly soluble. This is going to be aqueous. Now remember, I require that AQ to be on the soluble one if this works. So make sure you put that on there. Now let's look at barium phosphate. Either barium or phosphate, usually the polyatomic ion, is going to be on this list. And we look over here and we see that, yes, indeed, phosphate is in the insoluble list, and the exceptions do not include barium. Barium is a group 2A metal, not a group 1A. So it looks like this one is indeed our insoluble substance. Remember, we show that with a down arrow. That is required. And this will work, so now we need to balance it. So let's balance it really quickly. There are 2 phosphates over here on the right. So I'm going to need to put a 2 in front of here to get 2 phosphates on the left. That's going to give me 6 lithiums. So I better put a 6 here. And now looks like I've got 3 bariums here, but only 1 here. So I'm going to put a 3 in front of this barium, which is also going to give me my 6 nitrates, which matches this other side. So it looks like that is balanced. So I'm going to box this one. Now the last thing I want to talk about is what you can do for extra credit. And that is to put in the symbols for these. I would suggest doing them first and coming back and doing symbols later. If it's double replacement, all of the, or any of these substances at the beginning are going to be aqueous. They're going to be solutions that we're mixing together. So those are going to be AQs. That would get you some extra credit. It said this was liquid mercury up here, so putting that would get you a half a point. Saying that this is a solid would get you a half a point. And all ionic compounds, if they're not soluble and they're not in water, are going to be solids. So down arrow for HgI2. It's an ionic compound. Sodium, if you look at a periodic table that has color, all of the black ones are solid. If you look at ours in our classroom, black are solids at room temperature, red are gases at room temperature, and the blue ones, there's only 2 blue ones up there, and the blue ones are liquids at room temperature. And bromine and mercury are the only 2 that are liquids at room temperature. So sodium is black if you look it up, so it's going to be a solid. Cobalt, it's not in water, it says nothing about, it does say, it says it's a solution. Sodium, a piece of sodium is placed in a solution of cobalt-3 sulfate, so that's going to be aqueous, it just told us. Cobalt is a metal and it's black, it's going to be a solid. Sodium sulfate is in water, and this one you'd have to look up because it's still in water. This one will be a harder one, and it's got sodium, a group 1A metal, so it is going to be aqueous also. So watch for that one. That one's a little bit tougher. Okay, as far as this one, iron 3 oxide is an ionic compound, so it's solid. Iron is a metal that's black on the periodic table, so it's a solid. Oxygen, I would expect you to know oxygen, just common sense, is a gas, so it's going to get an up arrow. So that would get you some extra credit. And let's finish up with these down here. Butane is actually a gas. If it were on the test, I would probably tell you like liquid, octane, or gaseous propane or something like that, but this is a gas. Oxygen is a gas. It has to be a G since it's a reactant. Carbon dioxide, I would expect you to know that carbon dioxide is a gas. And think about it. This is a combustion reaction. It's going to be really hot, which is why water is going to be a gas as well. Both of these are solutions, even not an S, it should be an AQ. Even though it's no reaction, you could still pick up a couple of, pick up a point, a half point each for showing that these are aqueous. And you could do the same thing with this final reaction. Aluminum chloride, it says aqueous aluminum chloride, so you could put an AQ here. And bromine is one of our only 2 elements that are actually liquids at room temperature, so that would be a liquid. And all of those little abbreviations that I just showed you would get you extra credit on this test. So good luck.